Good morning. My name is Sarita. Today I am going to explain the concept of valency and valence shell. Before knowing the concept of valency and valence shell, let us see the structure of the atom. Atom is the smallest particle of an element. It consists of nucleus. It is surrounded by circular path known as orbit or shell. First shell is known as K shell, that is n is equal to 1. The second shell is known as L shell, n is equal to 2. Third shell is known as M shell, n is equal to 3, known as N shell or n is equal to 4. So the maximum first shell can accommodate maximum of 2 electrons. So the maximum number of electrons which is present in any shell is given by the formula 2n square, where n is the number of the orbit or shell. So here the nucleus contains neutrons and protons. Neutrons is neutral, protons are positively charged particles. Together they are known as nucleons. It is surrounded by circular path, that is orbit or shell, which contains electrons. The first shell will have maximum of 2 electrons. Next shell will contain maximum of 8. Next shell will contain maximum of 18. And the next shell will can accommodate maximum of 32 electrons. Now, valence electron. Now, the outermost orbit is known as the valence shell, and the electrons which is present in the outermost shell of an atom are known as valence electrons. The outermost shell of an atom can accommodate maximum of 8 electrons. This is given by Bohr-Bury rule. Completely filled outermost shell with 8 electrons show little chemical activity. It means its combining capacity is 0. Let's see the example. Hydrogen consists of nucleus in which protons are present and 1 electron is present in the outermost orbit. So its valence electron is 1. Helium, the atomic number is 2. It means 2 protons are present inside the nucleus and 2 electrons are present in the orbit. As a whole, it will be neutral. So the valence electrons are 2 in helium. Lithium, atomic number is 3. So the innermost shell has 2 electrons, which is complete. The outermost shell has 1 electron. So valence shell electron in this is 1. Similarly, for beryllium, atomic number is 4. 2 in innermost shell and 2 electrons in outermost shell. So valence electrons are 2. Boron, atomic number is 5. 2 and 3. 3 are the valence electrons. Carbon, atomic number is 6. 2 inside and 4 electrons in the outermost shell. So valence electron is 4. Nitrogen, atomic number is 7. 2 and 5. 5 is the valence electron. Oxygen, atomic number is 8. 2 and 6 electrons in the outermost shell. So 6 valence electron. Fluorine, atomic number is 9. 2 electrons innermost shell and 7 electrons in the outermost shell. So valence electrons is 7 in the fluorine. Neon, atomic number is 10. 2 innermost shell and 8 electrons in the outermost shell. So it has attained the octet electronic configuration. So valence shell electrons in the neon is 8. So these are the valence electrons of these elements. Next, valency. Valency means the combining capacity of the element with other element is known as its valency. That is, their tendency to react and form molecules with atoms of same or different element. Valency can be used to find out how the atoms of an element will combine with the atoms of another element to form chemical compounds. An outermost shell which has 8 electrons are said to possess octet electronic configuration. Atoms react to obtain octet in outermost shell to attain stability. This is done by sharing or gaining or losing electrons. Now let's see with example. Hydrogen, the atomic number is 1. The outermost shell has 1 electron, so it will lose 1 electron, so its valency is 1. Helium, The atomic number is 2. It has 2 electrons in the outermost shell. So the outermost shell has acquired 2 electrons. The maximum electrons can be accommodated in the K shell is 2. So it will neither lose electron nor it will gain electron. So valency of helium is 0. Next, lithium. Atomic number is 3. 2 in the K shell and 1 electron in the L shell, that is the outermost shell. So it will lose 1 electron to attain stability. So its valency is 1. Note: if the number of electrons in the outermost shell is close to octet, that is 8, then valency is determined by subtracting the outermost electron from the octet. For example, oxygen. The atomic number of oxygen is 8, 2 electrons in the K shell and 6 electrons in the L shell, as we have already seen. So valency will be 8 minus 6, that is 2. So instead of losing 6 electrons, it will gain 2 electrons to attain octet electronic configuration to attain stability. Next, fluorine. Its atomic number is 9. So first shell will have 2 electrons and next shell will have 7 electrons in the outermost shell. So as the configuration is near to octet, so its valency is determined by subtracting 7 from 8. So we will get 1. So instead of losing 7 electrons, it will gain 1 electron to achieve octet configuration for stability. So hence we can say atom of each element has a definite combining capacity that is called its valency. Thank you.